Welcome to module 13.7. In this particular lecture video, we're going to take a look at applications of quadratic equations. So this particular video, I want to show you how to solve quadratic application problem involving with numbers. So we are going back to do a little bit of translation, okay? And I will show you how to write out these type of equations involving with quadratic. So let's translate. I'm going to use one variable only for this problem. One variable will be a little bit easier to deal with. So let's translate real quick. One positive number is 4 more than, see the word more than? So this sentence is the sentence I need to translate. So in this sentence, one positive number is 4 more than twice of another. So I have one positive number and I have an other. So I'm only comparing between two different items. So I'm gonna let the item list at the end to be my x. All right, so another number gotta be x. This one positive number up front, that one positive number means equal. 4 is 4. More than means plus. Twice means 2 times. 2 times who? 2 times another. So that will be x. All right. Now this sentence, the next sentence will tell me how to write out the entire equation. If their product is 336, find the number. So that means one number times another number. Their product is going to be 336. So that will be x times 4 plus 2x. Okay, the two numbers multiplied together, their product is 336. There we go. Let me move this over a little bit. All right, so let's solve for it. So from 13.6, okay, step number 1 when we're solving quadratic equation is identify how many terms. So here I got 2 terms. My first term has parentheses, so that reminds me to do a distribution. So x times 4 is 4x. X times positive 2x is positive 2x squared, so that should be the degree of the polynomial. Therefore, my 2x squared got to be the first term. All right, so I go ahead and put the 2x squared as the first term. All right, equal to 336. All right, step number 3, combine like term if I have any, so I don't. Step number 4, let's move all the terms to the same side. Let the other side equal to 0. So I'm gonna move this 336 to the left side. So that gives me 2x squared plus 4x minus 336 equal to 0. All right, no like term to combine, so let's factor this. So I do have a greatest common factor 2. I can factor out, so I'm going to do that real quick. So that's 2 times x squared plus 2x minus 336 divided by 2. So that gives me 168. All right, equal to 0. So I don't believe I ever show y'all how to deal with problem look like this as far as solving quadratic equation. So basically, what do I do with this 2? This 2 that I factor out. Well, this factor 2 does not contain any variable with it. Okay, so what I can do is divide both sides by 2. Let me go back. What I can do is divide both sides by 2, because 0 divided by 2, that would just be 0. And this will cancel out, leaving with a 1 doing a distribution. So that means once I divide both sides by 2, my x squared plus 2x minus 168 can come in out of the parentheses. All right, so trinomial. Let's see. 2 parentheses right away. For x squared, I use x and x. So what do I do with a bigger number? So if my last term is a little bit bigger than what we're accustomed to, then we got to think about, okay, who times who will be 168 and have a difference of 2. What that means is the two numbers that I need for 168 got to be very close to each other in order to have a difference of 2. So let's do a little bit of thinking here, okay? Instead of going through a lot of them, instead of going through a lot of factors that give me 168, we can kind of think about certain numbers, okay, ahead of time. I know 1 times 168, okay, is not going to work for me. So let's do 168, all right, divided by 2. All right, so what I want you to see here in my calculator is the difference between 2 and the answer 84. That's 82. That difference is 82. I only want the difference to be 2. So that means my number that I'm choosing got to be what? Got to be a little bit bigger than just simply 2. All right, 3. 168 divided by 3 is 56. So once I use 3, my difference is now a lot closer. All right, we'll go into 4. Yeah, 4 and 42. Okay, I know 5 doesn't work. I know 6 will work because I already used 2 and 3, so I know 6 will work. So what I'm doing is basically finding all the factors of 168. So using 6 is already 6 and 28. Now the difference is only about let's see, 22 or so. All right, so I'm getting closer. 168 divided by 7, that's 24, divided by 8, 21, divided by 9. No, 9 isn't gonna work. All right, 168 divided by 11. The reason why I did not use 10 because I know 10 cannot go into 168. But what about 11? Nope. It's okay. I just say no, but look at the difference. Between 11 and 15 point something, the difference is 4. So the next one I will need to try will be 12. And that's what I want, 12 times 14. All right, so 12 and 14, the difference is 2. So that what I mean by that is my inner and outer, 14 on the outer, inner is 12. So the difference is 2. I need to, so my inner and outer must subtract to get to positive 2 in the middle. All right, since my middle term is positive, that means I would need more on the outer, positive 14 and negative 2. All right, so once I factored it, we set each factor equal to 0. So x minus 12 set equal to 0. And we will set x plus 14 equal to 0. All right, move it over to the other side. All right, my answer x equals 12 and the other x equal to negative 14. All right, now since the problem did say one positive number, that means my negative 14 cannot be one of my answers. All right, my answer needs to be positive. So that means my another number is going to be 12. All right, my one number is going to be 4 plus 2 times 12. 24 plus 4 is going to be 28. All right, so these two are my answers. All right, so I did went through a lot of different factors to come up with my answer earlier for the 168, 12, and 14. Now, I kind of already knew ahead of time the 12 and 14, I kind of already knew what my answer is gonna be close to. So let me kind of share that with you real quick. 168. I do want you to think about this. 168 is actually between 100 and 200. The reason why I'm mentioning 100 and 200 is because 100 can be think of as 10 times 10. 200 can be 10 times 20. So that means either way, in order to get to 168, I know my answer need to be somewhere around 10 and somewhere within 20. I know it will be within 20 because my difference is so small. Okay, my difference is only going to be a 2 in the middle. So that's the reason why, I can kind of guess that I will need to, my answer is going to be somewhere between 10 to 20 or very close to like a little bit below 10, okay, or a little bit bigger than 20. So this is the technique that we can use to deal with the bigger numbers, okay, for other examples. So it gave me a guide on where should I start, plug my number in the calculator in order to get what I wanted in the middle. All right, why don't we try another one, okay? One integer is 2 less than another. So again, same type of translation. Two items here. I got one integer and I got another. This time the problem does not say positive. So I'm actually going to have two sets of answer here in a minute. All right, since another integer is listed at the end, so that will be x. One integer equal 2, I write 2. Less than, I write subtraction sign in the front. Less than another, which is x. Alright, this is very strange. The sum of their squares. Okay. This translation means, okay, this is what I need to write out the equation. What this is saying is the sum, that means we add first, of their squares. That means they already squared. Okay. They're already squared, and then we're gonna add them up equal to 202. So I got one integer that is x minus 2, the sum of their squares. So that means that one integer, whole thing got to be squared. Another integer, whole thing got to be squared. Together equal to 202. Okay, that's how we translate the sum of squares. Okay, addition between two things. Okay. Their squares. Another integer and that one integer got to already be squared. All right, let's solve for this real quick. I got on the left side, I got two terms. Okay, my first term has parentheses, so that remind me to do a distribution. And we mentioned this several times before. X minus 2 whole thing squared can never be x squared minus 4. Okay, that is not what it is. This is perfect square binomial. So either you write this out as x minus 2 times x minus 2, do your FOIL method, or you can use the formula a minus b whole thing squared equal to a squared plus minus 2ab plus b squared. Okay, I prefer you memorize the formula, of course, because it's a lot easier. So if we use the formula, a squared, my a squared is x. So my x squared is x squared minus, take a number 2 times your a times the b. So 2 times x times 2 is going to be 4x plus my b, 2 got to be squared, which is another 4. Plus, okay, remember now, the second term is positive x squared equal to 202. All right, combine like term, x squared plus x squared is 2x squared. All right, minus 4x. So I'm gonna save a little bit of time, okay? I know my 202 in the next step got to be moved over to the other side. So positive 202 come over, become negative. It will combine with a positive 4. So that will be 4 minus 202. which will give me negative 198 equal to 0. All right. So right now, what I can do is factor out my 2 or divide every term by 2. Two different techniques to do this. If I will divide every term by 2 to shrinking my coefficient here, that should give me x squared minus 2x minus 198 divided by 2, which is 99, all right, equal to 0. All right. So I hope 99 is not too bad to factor with. 99 got to be 9 and 11. Because 9 and 11, the difference is 2. So my outer is 11, my inner is 9. To get a negative 2 in the middle, I got to subtract, right? Well, my last sign is negative, so inner and outer got to subtract anyway. To get a negative 2, I need negative 11 on the outer, positive 9 in the inner. All right, set each factor equal to 0. So x plus 9 set equal to 0. One of my answer is negative 9. X minus 11 equal to 0. The other answer, x equal to positive 11. All right. Now the problem never said positive or negative integer here, so both my answer are correct. So let's say my another integer will be negative 9. Then that one integer is negative 9 minus 2, which is negative 11. So this is one set of answer. The other set of answer is where another integer is 11. So that one integer is 11 minus 2, which is 9. Okay, so I'm actually having two sets of answer here. All right, this one is one number is 6 more than another. So this one is same translation as the previous ones. So I got one number and I got another. All right, so we're still going to let another to be x. That one number is 6 more than means plus. Another is x. Now this one says the difference between their squares. The difference between their squares is 204. So since their difference is a positive 204, that means we got to use a larger number, subtract a small number to equal to 204. All right. So since this one number is 6 more than another, so that means the one number is bigger than another. So that one number 6 plus x got to be in the front. Since this is the difference between their squares, so that was just like, this is just like the previous problem. My one number, whole thing squared, minus by another number, whole thing squared, who is smaller. All right, so let's see. So let's do this same thing. Okay, 6 plus x whole thing squared. We can use a different, we can use perfect square binomial formula, which is my first number is 6 whole thing squared plus 2 times my a times my b. 2 times 6 times x is 12x plus my b, which is x whole thing squared, minus another x squared equal to 204. So here's the thing though, when I combine like term, this is actually no longer, okay, this is actually no longer a quadratic equation. This has actually become linear equation because the highest exponent now becomes 1. So this is now a linear equation. So I'm going to have my positive 12x stay on the left side. So I'm going to move my positive 36 to the other side, become subtraction. So that's 204 minus 36, which is 168. Divide both sides by 12. My answer, x equal to 14. All right, so sometimes my quadratic equation, if the x squared term cancels out, it will then become a linear equation. So x is positive 14. So another integer is 14. So that one integer, 6 plus 14, will be 20. Excuse me. All right. So in this lecture video, we take a look at quadratic application problems of quadratic equation involving with numbers. So the next video, we're going to do a little bit of geometry application problem involving with quadratic equations, and we're going to do some consecutive integer as the last video of 13.7. All right, that will conclude this lecture video. Thank you for watching.